Hello and welcome to Apex Astro, your one-stop destination to explore the wonders of the cosmos. Today we're diving into one of the most explosive and fascinating phenomena in our solar system, solar flares. We'll explore what they are, how they form, the science behind their classification, their impact on Earth, and how scientists study them. Plus, we'll discuss some of the most powerful solar flares ever recorded. Stick around because this is going to be an illuminating journey through the power of our sun. Let's start with the basics. What exactly is a solar flare? A solar flare is a sudden and powerful burst of energy that occurs on the sun's surface. These flares are essentially explosions caused by the release of magnetic energy stored in the sun's atmosphere. The sun is a giant ball of hot plasma, and its surface is constantly in motion. This movement causes the sun's magnetic fields to twist and tangle. When these magnetic fields snap or reconnect, an immense amount of energy is released in the form of light, heat, and charged particles. To put it into perspective, a single solar flare can release as much energy as billions of nuclear bombs going off simultaneously. Now, let's delve deeper into the mechanics behind solar flares. The sun's magnetic field is created by the movement of charged particles in its plasma. These magnetic fields sometimes become twisted or knotted, forming regions of intense magnetic activity called sunspots. When the magnetic field lines in these regions become too tangled, they suddenly snap and release their energy in a massive explosion. This is what we observe as a solar flare. Interestingly, solar flares often occur alongside coronal mass ejections, or solar flares are classified based on their X-ray brightness. The classification system includes 5 categories: A, B, C, M, and X. A-class flares are the weakest with minimal impact on Earth. B and C-class flares are small and usually have no noticeable effects. M-class flares are medium-sized and can cause minor disruptions to radio communications and some auroras. X-class flares are the most powerful. These can cause radio blackouts, damage satellites, and even impact power grids on Earth. Each category is further divided into a scale from 1 to 9, with X10 or higher being incredibly rare and extremely powerful. Let's talk about how solar flares impact us here on Earth. The light and radiation from solar flares travel at the speed of light, reaching Earth in about 8 minutes. This can disrupt radio communications, especially in the high-frequency range used by airplanes and ships. More powerful solar flares can also damage satellites, affect GPS systems, and cause power grid failures. For instance, the 1989 solar storm caused a massive blackout in Quebec, Canada. On the brighter side, solar flares can create stunning auroras, natural light displays in the polar regions caused by the interaction of solar particles with Earth's atmosphere. Studying solar flares is crucial for understanding and predicting their effects on Earth. Scientists use advanced telescopes and spacecraft to monitor the sun in real time. One of the most important tools is NASA's Solar Dynamics Observatory, or SDO. This spacecraft provides high-resolution images of the sun in multiple wavelengths, helping us track sunspots, magnetic activity, and solar flares. We also use ground-based observatories and computer models to predict solar storms and mitigate their impact on technology and infrastructure. Throughout history, we've witnessed some truly massive solar flares. One of the most famous is the of 1859, the largest solar storm ever recorded. It caused telegraph systems to spark and fail, and auroras were seen as far south as the Caribbean. More recently, in 2003, the sun produced an X-28 class flare, the most powerful ever observed with modern instruments. Luckily, it was not directed at Earth, but had it been, the consequences could have been catastrophic. Solar flares remind us of the immense power of the sun. As we rely more on technology, understanding and predicting solar flares becomes increasingly important. For astronauts, especially those on missions to the Moon or Mars, solar radiation from flares poses a serious risk. Scientists are working on creating better forecasting models to protect astronauts and our infrastructure. That wraps up our deep dive into solar flares. We hope you enjoyed this journey through the sun's incredible energy and learned something new today. If you found this video helpful, make sure to hit that button, subscribe for more fascinating space content, and share your thoughts in the comments below. Let us know what you'd like to see next or how we can improve our videos. Thanks for watching, and until next time, keep looking up at the stars. Subscribe for more cosmic wonders.